This question was asked in the GATE Physics paper 2020. This is a numerical answer type question having 1 mark. The topic of the question is electromagnetic theory. The question is, far from the Earth's magnetic field can be approximated as due to a bar magnet of magnetic pole strength 4 into 10 to the power 14 ampere meter. Assume this magnetic field is generated by a current carrying loop encircling the magnetic equator. The current required to do so is about 4 into 10 to the power n ampere, where n is an integer. So the value of the n is, so we have to find the value of n here. One information is given in this question is Earth's circumference is 4 into 10 to the power 7 meter. Now let us see how to solve this problem. Far from the Earth's magnetic field can be approximated as due to a bar magnet of magnetic pole strength P equals to 4 times 10 to the power 14 ampere meter. Now we can assume that this Earth's magnetic field is generated by a current carrying loop encircling the Earth's magnetic equator. So the current carrying loop has the radius A, which is the radius of Earth, and the magnetic dipole is directing towards the north direction. The magnetic dipole moment is mu, and the length of the magnetic dipole is 2a. So magnetic dipole moment mu vector of the bar magnet of Earth is given by mu equals to p times 2a. So this is the relation between the magnetic dipole moment with the magnetic pole strength. Here a is the radius of Earth. Now assume that this magnetic field is generated by a current carrying loop encircling the magnetic equator. So in the diagram we can see there is a current carrying loop encircling the magnetic equator of the Earth having radius small a, which is the Earth's radius, and the passing current is I, and due to this current magnetic field will be generated and the corresponding magnetic dipole moment is mu vector, which is directing towards the north direction. The current required to do so is about 4 into 10 to the power n ampere, that is given in the question. So our current I equals to 4 into 10 to the power n ampere. We have to basically find this n value. Now we know magnetic dipole moment due to a current carrying loop having radius small a is given by mu equals to I times pi a square. Now we will compare the equation 1 and equation 2. So equation 1 was magnetic dipole moment is equals to P times 2a, where P is the magnetic pole strength, and also for the current carrying loop the magnetic dipole moment is I times pi a square. So we will equate that two equations. So we will get P multiplied with 2a equals to I times pi a square. So from here we can get I equals to P times 2a divided by pi a square. So this will give I equals to 2p divided by pi a. Now in the question it is given that the magnetic pole strength P equals to 4 times 10 to the power 14 ampere meter. The current is 4 into 10 to the power n. Earth's circumference, that is 2 pi a, is 4 times 10 to the power 7 meter. So we'll use this information in this equation. So we'll get 4 into 10 to the power n equals to 2 times 4 times 10 to the power 14 divided by 2 times 10 to the power 7. So here 2 and 2 will be cancelled out from the numerator and denominator, and from the left side and right hand side the 4 will be cancelled out. So effectively we will get 10 to the power n equals to 10 to the power 7. So the value of n is 7 for this question. We can also solve this problem in an alternative manner. The definition of the pole strength is given by P equals to surface integral of H vector dot ds vector. So we are considering the Earth's magnetic field is due to a current carrying loop having radius small a. So for that current carrying loop, the H field is given by I by 2a along the z cap direction. So here it will be along the north direction. So from the definition of pole strength, we can write P equals to H times area of the loop, that is I by 2a times pi a square. So it will give the pole strength P equals to I times pi a divided by 2. We can write it as I by 4 times 2 pi a. So here 2 pi a is the circumference of the earth. So we'll put the value of P here, that is 4 into 10 to the power 14, and I value is given in the question 4 into 10 to the power n divided by 4 times 2 pi a, that is circumference of the earth, that is 4 times 10 to the power 7. So if we just cancel out the 4 and 4 from the left hand and right hand side, and from the numerator denominator the 4 will be cancelled out. So effectively we will get 10 to the power n equals to 10 to the power 7. So by comparing we can get n equals to 7. We solved this problem using two different methods, and from the solution we found that the current required to do so is about 4 into 10 to the power 7 ampere, where n is the integer. So our n value is 7 for this question.